Today we are looking at unit number 7 and it covers the mechanical systems and control. And the learning objectives are that after you have completed this unit, you must be able to demonstrate your knowledge and understanding of cranks and pulleys. Okay, only two things, which are cranks and pulleys, and they fall under complex machines. In this unit, we will discuss mechanical systems and control. Machines provide mechanical advantage. You remember in term 1 when we were doing levers and gears, we have talked about mechanical advantage. Okay, so they say machines provide mechanical advantage to make work easier. A mechanism or machine makes it easier to perform a task. Like all the other chapter, we've got important terminology. So we've got only two terms that we need to know for this unit. The first one is machines. Machines consist of simple connected mechanisms that work together to perform a task and or make it easier. And mechanisms, they change direction or magnitude of forces to make it easier to perform a task. Please know this difference between machines and mechanism. And we move to the next page, 133, which is lesson number 18 now, complex machines. And we will start by focusing on the cranks. Okay, so we'll focus on cranks. Okay, so it says here a crank consists of an arm. You see the arm attached at the right angle at 90 degrees. See, this one is horizontal and we have this 90 attached at 90 degrees. So a crank consists of an arm or handle attached at an angle 90 degrees to a rotating shaft or crank shaft. Okay, so this is a rotating shaft or crankshaft and the arm is attached there. Okay, and if you look at the bicycle pedal and sprocket there, the rotating shaft, and the arm is attached. Same with this one, we have a rotating shaft here in the middle and the arm is attached. Okay, let's go back to that paragraph. They say a crank consists of an arm or handle attached at the right angle to a rotating shaft or crankshaft, which is connected to and rotates around an axle, which is the crank. The crank makes it possible to exert a large force on the shaft and gain mechanical advantage. A crank converts rotary motion into linear motion. This is important. A crank converts rotary motion into linear motion. For example, the crank in between the bicycle pedals and the chaining mechanism that pulls the chain into the drive of the bicycle motion forward. Okay, so this is the rotating the pedals will give the rotating motion, but this crank will be connected to a chain that drives a linear motion. Okay, that is the cranks. So you must know the purpose for the crank. What does it do? It converts rotary motion into linear motion. Then we look under complex machines. So we look at pulleys. A pulley is a wheel with a groove that allows a rope. So this is a wheel and this passage is a groove where a rope will be. So a pulley is a wheel with a groove that allows a rope, cable, belt, or chain to run over the pulley inside the groove. So the cable will be here inside this opening. The wheel turns on the axle shaft. This is the wheel, it will turn. This is the shaft. Okay, this is the axle shaft. Because the pulley wheels turn on an axle, there is minimum friction. Using one pulley doesn't provide any mechanical advantage. However, using a pulley system of 2 or more pulleys does provide a mechanical advantage. Okay, on the next page, page 134, we see now a single wheel pulley. You see that well, and there's a cable on the pulley and there's a weight there at the bottom. Okay, let's read. Pulley systems consist of 2 or more pulleys. It is used to obtain mechanical advantage as it reduces the force needed to lift heavy objects. Okay, so when you use a pulley, you can even lift objects that you cannot lift with your own because you provide or you increase the mechanical advantage. The more pulleys in a system, the easier it is to lift heavy loads. But the further the rope has to be pulled. The example below has one pulley attached to a fixed point and one pulley attached to a moving point. So one pulley, this is a fixed point, one pulley to a fixed point, and the second pulley is attached to a moving point. Okay, where are we? The example below has one pulley attached to a fixed point and one pulley attached to a moving point. One loose end of the rope is attached to a fixed pulley. You see, the other end is on the fixed pulley. When the other loose end is pulled, the moving pulley moves up. Okay, so if you pull this rope, even this pulley will move up. Look at activity again to understand the complex machine. So this brings us to the end of complex machines, which are covered in lesson number 17 and lesson number 18. And this brings us to the end of work in term 3. Okay, so the next lesson we are just going to look at the practical assessment task that you will need to do for term 3.